All right, so here, just going over the first few questions, it looks like everybody was okay on these. Here was the picture that we were provided with, and we were asked to figure out if these triangles were equiangular, right, or obtuse, or I think the other option we had was acute in the choices. So we were classifying the triangles described by what? These are important details. What were we classifying the described triangles by? Angles, right? So at the beginning of class, someone even asked, like, what's the difference again between equiangular and equilateral? So who can tell us the difference between equiangular and equilateral, Jonah? Yes. Good, thank you. So it all depends on what you're given. You can make conclusions after you're given it, but we should all be good. So 1, 2, and 3, everyone's fine? Okay, nice. Next, numbers 4, 5, 6, and 7. I did some scrap work down here. Some of it's not really necessary. I just wanted to give options. So here was the drawing in the book. I redrew it because I'm being a nice student over here. And the questions in the book asked us for the angle measures. So I used the fact that, say for angle 1, I just did that angle 1 plus 125. These two neighboring angles should be a linear pair, adds 180, so on and so forth, right? 4 and 125 are vertical. Even though this looks like a right angle, please don't make any, what word am I going to say? Assumptions. Good. Don't make any assumptions. I know it might look like it at first glance. Do not do that. So angle 2, if you do the work, you should have gotten, I believe, 23. I haven't checked my answers with the back of the book, and I was multitasking. So let me know if I make a mistake, okay? 62 plus 23, well, that adds up to 85. So it's actually an acute angle, right? Are these angle measures all in line with what you guys had on the backboard? They look okay? Yeah. All right, nice. The next set of problems. The next set of problems, we were given 2 triangles, these 2 that I drew in blue right over here. And then they also gave us the fact that the 2 triangles were what to one another? Good, congruent. If they're congruent, we talked about this the other day. That means angle R is congruent to angle X, angle S is congruent to angle Y, and angle T is congruent to angle. Good. And then for side lengths, one thing we said is they go in order of the letters. So RS is a side. RS is congruent to XY. ST is congruent to YZ. And last TR will be congruent to ZX. Whatever order, we know it's interchangeable. So I was given R and X, and they happen to be congruent. So the 3 dots in a triangle, anyone remember what that means? When I write 3 dots in a triangle, it's shorthand for the word. It starts with a TH. I've probably just mentioned it quickly in passing. Therefore. So it's like this is given, therefore. Okay, 3 dots in a triangle is shorthand for therefore. Angle R is congruent to angle X. I plopped in that information. I found Y, and I found X. Honestly, I did those, and then I read the questions that were just asking me for X and Y. And not that beefy of a question. They didn't even ask me to find angle X, right? Or, angle R, or the side length. If X is 35, to find angle X, I would just plug it, if Y is 15, plug that in, 45 plus 5, that's 50 degrees, right? Not even close to being to scale. Do you guys see that? So you can never assume it's to scale. All right, we're good on 9 and 10? Yes? Nice. Okay, next was the question that was the proof. It did say to write a flow proof. I'm not going to write a flow proof with you guys. We're going to just do 2 columns like I mentioned just a few minutes ago. So given this information, now, like I keep suggesting to you guys, I think it's always a good idea to kind of chip away at things as you read it, add it to your pictures, whatever you got to do. I'm going to use everything that was given to me, I have written in blue. So I'm going to do any of my work in red. I think you guys can see the red pen's pretty okay on here. So number 10, given XY is parallel to WZ. Again, let me know if I copied something from the book incorrectly. XY is parallel to WZ. Here's XY, here's WZ, and they're parallel. So I'm just going to go in my picture, and I'm just going to mark up that they're parallel with my little arrows. Make sure you don't use the tick marks. That means they're congruent. That means they're the same length, right? Just because lines are parallel doesn't mean they're congruent. What polygon, what quadrilateral has parallel sides that are not congruent in length? Sophie? Trapezoid. Nice, the trapezoid, right? The top and the bottom, depending how you picture it. Top and the bottom could be parallel, but one will be longer or shorter than the other. Okay, other one, XW parallel to YZ. So that's going to be these sides. Now, I'm going to use a double arrow this time to show that it's, 2 different sides, that they're parallel. Now, just from that information alone, when you have parallel lines, another thing I mentioned is helpful is extending your lines past your polygon or your, if you have a triangle or a trapezoid, whatever shape you have, extending your lines, your line segments past it, because it helps you see what kind of angles sometimes. What does this help you kind of, not necessarily just right, but. Like supplementary. Okay, supplementary. What other types of angles? Anyone? Alternate. Sure, alternate interior. So I'm even going to highlight some alternate interior angles, for example. If parallel or not, parallel or not. That's what some of the quizzes were about, and some of you guys were concerned because you're like, I think there's mistakes, I'm not getting answers right. Make sure you come ask me questions at lunch. Some people did when they weren't sure of stuff, but people were like, I thought alternate interior angles were congruent. When are alternate interior angles congruent? Right, when you're dealing with the parallel lines and a transversal. They're still alternate interior by definition. They're only congruent when lines are parallel, and vice versa, the converse. If they're congruent, then the lines are parallel. So I just highlighted some alternate interior action right over here. So 2 is congruent to 4. Okay, it might be easier to see when you draw it that way. And then in, say, blue over here, if you drew another kind of Z shape, I do also have here, 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 to make another looking Z right there. Okay, so statements. Step 1, let's write down what we were given. That's usually a great starting point if you don't know where to begin, so you could get as much partial credit as possible. So that's parallel to that, comma, save some space, and XW parallel YZ. And the reason is, well, because it's given. All right, now, based on them being parallel, I kind of went in here and I marked up their parallel, and we saw some relationships. What can I write down maybe for step 2, Marin? Angle 2 is congruent to angle 4. And let's do it both in one shot. What else can I write down, Ella? Nice. Angle 1 is congruent to angle 3. What reason can I write down? Delilah? Yeah, alternate interior. Obviously, I think we can just say we know it's because they're parallel. Alternate interior angles, congruent, being a little lazy there, okay? Alternate interior angles are congruent when dealing with parallel lines. All right, what else can I write down? Let's look at where we're trying to go. We're trying to show that triangle XWZ is congruent to triangle ZYX. Now, one thing that's helpful when you're doing a proof is to take the picture and draw it where you will have 2 separate triangles instead of drawing it where they're like touching or sometimes overlapping. I know in the do now yesterday, Vic, you asked me about that one question. You're like, there's so many triangles here. How am I supposed to know which ones we're talking about? Because they were overlapping. You know which one I'm talking about? Yeah. From yesterday? Yeah. So when they're overlapping, it's really helpful. It gets hard to do it in your head in the beginning, but you guys will get better at it. But picture them separated. So I'm going to picture that I ripped these 2 triangles apart a bit. So I'm just going to sketch over here. Here's one triangle, and over here is another triangle. I'm just trying to draw straight edges, not to scale at all, make believe. Okay, so I have this little drawing down here. Just going to add the letters back. There's W, there's X, there's Z, but that's also X, that's also Z, that's Y. Angles that we said were congruent, well, we said 1 and 3. So this angle is congruent to that angle. And we also said that angle, well, not X and Z, I'm sorry, 1 and 3. That and that. So that's what I have so far. And I want to prove that these 2 triangles are congruent to each other, right? That's what I'm trying to prove. It still says that on top. Maybe that visual helps a little bit. But so what else can I say, Thaddeus?
That, well, X to Z is congruent to X to Z.
Yeah, perfect. And I feel like that gets overlooked because it seems like well, duh, of course they're congruent. What allows us to say this?
Reflexive.
Nice, reflexive property. So that was the one I said. It's like you cloned the side XZ, so now I have 2 of them. That means that we can take apart the triangles. So say you had 2 dogs, right, and they fought with each other all the time. So you put one dog in one little, pen cage thing, when you have the little walls and you kind of fence them off, and the other dog in another one, but you didn't have that much fencing, so they share a wall. Well, if you needed to separate them, you need more fencing. So you need to clone this to acknowledge that you have 2 of them. So if I may have even redrawing it, I had to clone XZ, so I have 2 of them. There it is, okay? So reflexive property. So I now have that this piece is congruent to this piece. I can even put 3 tick marks so it's different from the angles. Now what? Look what we got. Think about all the stuff that's, say it again? Nice, so I know ASA, is that gonna go here or here? Reason, exactly. Angle, side, angle. And what statement can I write with that? Sorry, say again? Triangle, XWZ. Nice, ZYX. So we got to the finish line. Those 2 triangles have to be congruent because we have the rule that if you have angle, side, angle, it matches up over here, angle, side, angle. So X, you don't have to draw that anywhere. I just drew it for your own visualizing. You don't have to draw it, but you just think of them as 2 separate triangles, right? And you realize that this side, XZ, it's a part of this triangle and a part of that triangle, So we are using the same side. Obviously, if it's the same side for 2 triangles, it has to be congruent to itself. And that's what allows us to use the angle, side angle. written down, all I had was the angle and the angle at first. That's not enough information. Angle, we'll do later. That can prove that two triangles are not congruent, but what was the other word? Similar. Nice, that they're similar. That means just in the same ratio, okay? They're proportionate to one another. We're okay on this one, we think? No questions? All right, next. So over here, number 11 was a multiple choice question. Always pay attention. I think a teacher's favorite thing is when students think that these are all separate parts and they try to come up with answers for each thing. I don't know what you make up. Or when it's part A, part B, part C, part D, and students circle one. And it's not multiple choice, so always be aware. So it says find X, and then we were given all this information. What can I do to get started? Find X. What can I do to get started? Ellie. Okay, let's say 180 minus 116. From there, Isaiah, after I subtract 180 and 116 and I get, what is this, 64? I get 64. Why did Ellie have me do that? She did 180 minus 116. Why?
Because the two angles, in this triangle we have two
Congruent? Two congruent what?
sides.
Good. What kind of triangle does that make it? Has a special name. Who remembers the name of it, Tristan? Isosceles. So if I have an isosceles triangle, two congruent sides, what other conclusion can I make? Good. Which two angles are going to be congruent? Is 116 one of them? No, it's the other two, right? So she subtracted 116, got 64, because that's what's left for these two angles. What can I do next? Alana, what can I do next? If I have 64s left? Nice. I'm going to divide that by 2, and I get 32. Caitlin, what can I do with this 32? Nice. Each of these angles is 32. Sure. We're just kind of going like a stream of consciousness, writing down a whole bunch of stuff that we know. All right. Now, drew my picture. I have 32. Well, I also have 72. I have this other triangle. What else can I do? Even if you don't know if it's going to get you to the finish line. Lindsay, what else can I do? Why? Because 32 plus 72 plus L for Lindsay, that's an L, has to equal, because it's a straight line, right? I can't really call it a linear pair because it's 3 angles, so that would be weird. Okay, so she said to add these two and subtract from 180. Exactly. So here's the equation that's letting us do that. 30 and 70 is 100, so 32 and 72 is, anyone? Beautiful. 104 plus L for Lindsay is 180. Then we're subtracting 104. 180 minus 100 is 80. Take away 4 more. L equals? Nice, 76. L equals 76. So Sydney, what can I do now that I know L equals 76, which is that angle down there? Yeah, because it's what kind of triangle here as well? Good, so that's also 76. Okay, so I got 76 here, 76 there. From there, what else can I do, Griff? Right, because 76 plus 76, my two isosceles angles there, they're congruent angles, plus x equals the whole triangle, which is 180. 70 and 70 is 140. 6 plus 6 is 12. Good, so 152 plus x is 180. 180 minus 150 is how much? Minus 2 more. So x equals 28 for the answer. We should have all picked choice C. Did we get it? Yay. Don't do guess and check. That's very silly. Okay, so that was 11. Next is number 12, and I just pulled a piece of sticky graph paper for myself to do this question, and I didn't set it up for us all yet. So if you have a graph paper notebook, then that's great. If you would like a piece of sticky graph paper, come grab it. It's next to the stapler over there. Sorry, it's a little wrinkled. It's Post-it brand. So if you ever want that for your notebook, that's available at like Staples and stuff. So that could come in.
Well, do you have to like draw them?
No, you don't have to, but sorry, I'm shaking up the camera. Okay, we'll find out. So there might have been an error somewhere, or maybe, you did great, and maybe they do intersect, so we'll see. And then you gave up. Well, that's not the spirit, Jonah.
For the rest of them, I got 1 through 9, and then 10, but now I understand. Well, 11 actually.
I'm just going to scoot that over there. I'm just going to zoom out a bit because I'm super close and I don't want to be that close. Okay, so I just have the information up top so I could rewrite it quickly, but number 12, your given information was you were trying to determine, so it says determine if those are congruent. So I'm going to write not prove, but try to prove. What am I trying to prove? That triangle TJD is congruent to triangle SEK. Now, the fact that I don't have any letters repeated means that they're not going to share really a side or an angle. The triangles could overlap, but they're still two distinct triangles. If they overlap, did anyone else get your triangles overlapped, you were saying, Jonah?
Yes.
Did anyone else get if they drew it two overlapping? So if that bothered you, like it's fine, but if that bothered you, you could graph them on like two separate XY planes to make it easier for yourself to look at. You know what I mean? Like draw a little coordinate plane and another one. This way they don't have to overlap, but it's okay if it does. So we want to do that, and then we have some points over here. So it says T is -4, -2, just jotting this down. J was 0, 5. Big mistakes, I'm putting a star next to this. Why do I put a star by this after I said the words big mistakes? What do people do wrong all the time to make me sad? Who can think they figure out why that point would get plotted incorrectly? What do people do? I'm not looking up, so yell it out because I'm writing. What do you think? You guys will plot the rest of these points fine, but the second I ask you to plot something like J, that's when you guys mess up. Why do you plot J incorrectly? What do people do by mistake? Anyone? Anyone? It started snowing out the window and everything. That's it. We're gone. No one? What you guys like to do is you assume it's an x-intercept when it's a y-intercept or vice versa. You know, like you put that 0 in the wrong place in your head. So just be careful of that. Okay, just be aware, go slow, slow and steady. Okay, now I'm gonna look at my points here before I draw my plane. A lot of you guys just go wild and draw your plane. What's my smallest x value?
-1.
My smallest x, I even see smaller. My x's go from -4 until, what's the biggest x value? 10, good. And then my y value is, what's my smallest y value? -2 maybe?
Yeah.
And then what's my biggest y value? 4, 5? 5. Now, I write that down so I can be conscious of where I draw my axes. So my y-axis, I need 7 units really, from -2 to 5. And this, I need 14 units from -4 to 10. So I'm going to go essentially down about 5. 1, 2, 3, 4, 5. All right, and then I'm going to go this. I'm going to say if that's -4, then I'm going to go over from there 4 units. 1, 2, 3, 4. That'll be my y-axis. And then I go 10 all the way. So 2, 4, 6, 8, 10. Go ahead. Ooh, that's why. You guys, thank you. I'm the silly goose. Silly me. Thank you. That's why I like a erasable pen. So rewind. -4. What did we say the biggest x was? 1, 4? +4?
Yeah.
Thank you. I'm sorry. So sorry. And then y is -2, and that's 10. Thank you so much. Okay, so recap. That messes that up, huh? Okay, so then my x's went from there. So this is 8 units in length from -4 to 4, and that's 12 units in length. Okay, so my y goes as high as 10 and as low as -2. Let me see how many boxes I have. So this, if I started here, I could go 2, 4, 6, 8, 10, 12. I do have enough room, and definitely enough room this way. Okay, so if I start up again from 10 will be, okay. So I'm going to draw this axis here. So just by checking that out, right? So I'm going to use a ruler because I can't draw a straight line with even a line helping me. So here's my x-axis. That should be better for me. And if I say that's -4, am I on the screen yet? Then that's -2. Then this is my y-axis. Right there. And I think I said that that would be +10. And there's my axis right there. And then just scooting over, I'm going to go 2. It's -2. I'm just going to label every other. 4, 6, 8, and this is way too much, right? I only need it up to 4. I forgot again. So I'm good. I have more than enough space here. Okay. So I go out to there. And then as low as -2. I'm good this time, right? Thank you. So careful planning. Obviously, if you're doing anything in life, careful planning is obviously an optimal way to use your resources. So I just wanted to make sure I didn't waste paper. So I just kind of assessed the situation. I did make a mistake, and thank you for catching it. So y-axis is this one, and x-axis is here. All right, so I'm just going to plot my coordinate points now, get everything there, and I'm going to do them each in a different color because Jonah warned me that they're going to overlap. So -4, 2, that's this point right over here, and that's point T. Next, I have 0, 5. That should be up here. 0, 5. That should be point J. Am I correct? Oh, -2. Thank you. I saw Thaddeus' hand go up, and my brain started realizing I must have made a mistake. Thaddeus, about to correct me.
Also, you put -4 on -5.
I put -4.
Yeah, like the X.
Oh, I plotted it in the wrong spot, too. Wow, I'm on fire today, huh? Thank you. So that was point T. Am I better now? We're good? Okay, thank you. Guys, yell it faster if you see it. Just yell at me so I don't continue. Then D is 1, -1, over 1, down 1. Can someone get that? Someone stepped out for the... Is Thaddeus going to walk across the room to open the door? And then that's point D. Okay. From there, I can connect those. If you have a ruler, obviously that's great. So I took this ruler because I hate having such a big ruler all the time with my stuff. And I snapped it in half because more often than not, the reason I need a ruler is because I need to draw a straight line. So I just broke my ruler in half to draw straight lines. Does that look okay there? All right, my next figure. Now, if they're giving me coordinate points, let's just brainstorm. If they're giving me coordinate points and they're asking me to prove triangles congruent, which way do you think I'm going to go ahead and prove triangles congruent? What do you think I should do if you have 3 ordered pairs per triangle? Any ideas? Marion, you kind of raise your hand for a second. You use distance formula, okay. Who else did distance formula? A couple of us, okay. What else can we do? Anyone have another idea? That's S. E was 3. I wouldn't measure with a ruler, but SE is 3, 10. E. And 4, 4 is K. No one else did anything different? If they're going to be congruent triangles, and this might not be obvious right away, and it might not work all the time, but we learned a bunch of different options for proving triangles congruent, like side angle side, right? If I could do distance formula here and here, I get 2 side lengths the same. We said that's not enough information, but an angle could definitely come in handy. Now, I don't know if this angle is congruent to another angle just yet, but sometimes you could figure out that you have a right angle from coordinate geometry. How could I figure out I have a right angle when all I have is a bunch of plotted ordered pairs? What can you do to find an angle or something about an angle if it's 90 degrees? What might happen if you have a 90-degree angle? Who remembers? There's a P word that deals with right angles, and we talked about that when we did linear functions, linear equations. Not Pythagorean. Think about linear equations, which is like Algebra 1. We did it in our review unit at the beginning of the year. We have linear equations, and we could have linear equations that have something in common with the letter P, or they could have parallel lines, or you could have lines that are perpendicular, and perpendicular lines make what kind of angle? A right angle. So that could come in handy as well sometimes. So what do you know about the slopes of lines with right angles? What do you know about the slopes of lines, Thaddeus, with right angles?
They're opposites.
Right, so they're, right, pun intended, not intended. Right angles have opposite reciprocal slopes going into them. So if I just glance, what's the slope of SK? We went up and over. The slope here is? How much do you go up and how much do you go over? Count boxes. 1/5, good. If this slope was -5, unfortunately it's -6, but if this slope were -5, it would be nice because you'd be like, oh, that's perpendicular to that, that must be 90. Let's check if these slopes are parallel by counting, if that's also 90. Do you know what I mean? So always keep your options open. So if we did distance formula, I'm just going to save a little time and trust that you guys did it. What did you end up getting from distance formula for the length of TJ? Who got the length of TJ? No decimals, please. What did you get for the length of TJ? Go ahead, Ella. Radical 65? Thaddeus, did you get the same thing?
Yep.
Okay. Anyone else get radical 65? Couple of us?
So
No.
when you did the distance formula for the points.
Yeah, I think the distance formula is a little quicker. For the coordinate points, it might be the quickest way, okay? This would be really time-consuming for a test question, but, just to have set up and be familiar with what you would do. Now, did anyone do SE and get the same length? Tristan, did you do it? Go ahead. Lena, did you get length of SE with distance formula? Okay. She, with her laryngitis or whatever over there, also got square root of 65, so that's SE. So that's good. So those are congruent, right? They're congruent to each other. If we follow through and finish, do you guys get that all 3 sides are congruent?
Yeah.
We did? So what way are we allowed to state that the triangles are congruent then? I'm going to write out what it is. Say, yes, they are. Actually, I did the answers in red. So, yes. Why are they congruent? Because of? Is my only companion today, Thaddeus, Kaden. If all sides are equal, why are they congruent? All the sides are congruent. We have a bunch of letters that we've been using as abbreviations. On the backboard, people wrote SAS, ASA. Yeah, it's SSS. All 3 sides are the same. 2 sides is not enough info. Side, 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 they're congruent. So winner, winner, chicken dinner. Okay? What is distance formula? Elia, do you know distance formula by heart?
E equals radical S to
Good. Make sure you know it. Make sure you're not putting the squares, the pluses, the minuses in the wrong place. You shouldn't have to look for the distance formula when you do these. You should be able to do them easy peasy all the time. Okay. What else can we try to do here? Let's look at number 13. 13. These I think we could kind of do out loud. It's a little bright. We could see it though? Yes. Determine which postulate or theorem. So this is sort of like the quizzes that I gave you guys for the do now for homework. Postulate or theorem can be used to prove each pair of triangles congruent. If it is not possible to prove them congruent, write not possible. Now, I have them touching side by side. That tells you you have a congruent side, right?
Mm-hmm.
This side is congruent to itself in the two separate triangles. Does that make sense?
Yes.
It's kind of like the one I pulled apart. So if you wanted to look at it that way, you could. Do you guys want me to redraw it, or can I do it from here?
You can
Do it from here? Okay, so we have angles congruent, sides congruent. That would be AAS. Is that a thing?
Yeah.
Yeah, and does that say that they can be congruent?
Yep.
Yeah, so let's say check, they can be congruent by angle, side. So I will write it down over here just so we can compare it in a second. What about 14? What can prove to us that those are congruent, two congruent triangles in there? Vic, do you know for 14?
Yeah.
What would let you prove those two triangles congruent?
Side.
Nice, side, because again, reflexive property, that line is congruent to itself. 15, Isaiah, what can tell us that those two triangles are potentially congruent to each other, or is it not possible? Not possible. Just because they're both isosceles and share a base does not mean they're congruent to each other. Did everyone catch that was not possible? It's a little sneaky visually because I feel like sometimes you're rushing and you make a mistake. How about number 16? Number 16, are those congruent to each other? Christina? Yeah, by what? SAS, okay? Side, angle, side. So again, those are my answers right over there, 13, 14, 15, and 16. We're good? I'll redraw the pictures in this work myself later. Okay, now we have this landscaping question. So as I read it, I'm going to draw it on the side and pull my paper on the screen. So number 17, we say, Angie has laid out a design for a garden consisting of two triangular areas as shown below. The points are A, B, C, D, and E as labeled. Now, if you want to, again, draw it if you have a graph paper notebook, amazing. If you draw your own coordinate plane, amazing. If you can keep track in your head, that's great too, whatever you need to do. So if I plot these points, kind of nice because the numbers are nothing too crazy. A is at 0, 0. B is 0, 5, so just up 5 units from there. Hopefully you sketch that. C is 3 units to the right of that. D is 3 units to the right of that point, and then down 6 more is point E, and we have our picture. Okay, now from that picture, moving the book, sorry, I'm going to put my picture back underneath. Here's my drawing, okay? I didn't draw the axes, I just pretended that that was the origin and took it from there. Now, what do they want to know about these triangles, Sophie? What's the question asking us to do?
Name the type of congruence transformation for the pre-image.
Oh, okay. So congruous transformation, really, this question, I didn't see it when I was glancing and assigning. I shouldn't have given this to you, but maybe you figured it out because we're going to do all our transformations later in the year. But a congruence transformation is basically saying if you have a shape and you do certain things to it, it's still congruent, right? Like triangle ABC, if I do this, isn't it still congruent to itself?
Yeah.
Like who cares? We just rotated it a few degrees. If I rotated a full 90 degrees, well, it's still the same figure, right? If I took it and I flipped it like that, same figure, yada, yada, yada. So I would say, again, we're going to do this later in the year all in one unit. This is a reflection over that line, right? Can you guys all see it's reflected? So not a big deal. You probably have used these words in other math classes in the past. Over the line. Now, I could even say the equation of the line that is reflected over, because remember, these are coordinate ordered pairs. That implies that it's on the xy plane. So there's my y-axis, and that's my x, according to the ordered pairs provided. What's the equation? Who can tell me the equation? Just while we're here, go over some linear equations. What's the equation of the line that we're reflected over? This is the line, I'm highlighting it, but I need to know what its equation is. It's a vertical line. Equation of the vertical line that we are actually reflected over. That easy to remember?
X equals 3.
Beautiful. X equals 3. Vertical lines are always x equals something, and horizontal lines are y equals a number, right? So x equals 3, and I told you at the beginning of the year, I gave you a little, I always remembered hey vex. Hey vex, horizontal equations are y equals, and vertical equations are x equals. So that's a little tip to help you out. You can use that. All right, easy peasy. Find the measure of each numbered angle was next for number 18. Were you able to get those answers with no problem?
Mm-hmm.
We're seeing the relationships that are all there. So triangles there. Again, even if it looks like a right triangle, do not assume it's a right triangle only work off of given information. The angles that are actually acute might be obtuse. You know, like it's not necessarily drawn to scale. So here I go. I got those over here. That was given as 24 degrees. Oh, sorry, I'm cut off. 24 degrees. Then we had angles 1, 2, 3, 4. So 1, 2, 3, not 3. Yes, 3 and 4. And we got two pieces congruent, that, and that angle given 66. If these are both congruent, what can you guys say about this triangle over here, Elia? What can we say about this triangle? Not equiangular. Equiangular means all the angles are the same. They would all be, it's isosceles. So what angle will also be equal to 66 then? Caden? 1. So angle 1 is 66. Like before, you'll do 180, take away 66 twice to get angle 3. Who got the measure of angle 3 for me? Angle 3 is? Caitlin, what'd you get for angle 3? Did you get that one? Griff? Yes. 48? Is he right? He said it with a question mark at the end of his voice. Yes? Caitlin? He's good? Okay, thank you. Anyone disagree? Because I'm trusting him.
Why is it angle 1 not angle 3?
Say it again.
Why is angle 1 66 not angle 3?
These are marked up as the isosceles, the congruent sides, right? When you have an isosceles triangle, if this is congruent to this, the angles opposite those congruent sides are also congruent. So what angle is opposite of this side? Opposite angles are the non-adjacent. So angle 1, okay? And then 66 goes with that one. So that would mean these are congruent, okay? Good question. All right, so that's angle 3. Angle 4 I might get next. Alana, how do I get angle 4? From 180, good. And what do you get, Alana? 132, she subtracted correctly. Everyone believes her? Last but not least, we have angle 2. Angle 2, what do I get for angle 2, Lindsay? Is it 24 for sure? We're good? How did you get it for angle 2? I'm sorry, say it again. Yes. Good, okay. I just want to make sure you weren't assuming that they were congruent, because like sometimes you can get the right answer by mistake. So I just want to make sure. So if you assume that this was isosceles and you're like, oh, angle 2 is 24 because isosceles, that wouldn't be correct. That's why I asked her how she did it. 24 plus angle 4 plus angle 2 should equal 180. We have angle 4 is 132, right? Sorry, is it blurry? No. So 24 plus 132 plus angle 2 is 180, showing my work. 24 and 32 is 56, 156 subtracted over. Angle 2 is equal to 24 degrees. Then we can say that that's congruent, right? Not only can we say that's congruent, what can I say about this point in regards to this line segment? What can I say about this point on this line segment? It's the midpoint. Yes, thank you. So those angles are all done. And last question was, 18 and 19 are essentially done here, right? 18 was angle 1, number 18. And 19 was number
2.
Angle 2. Oh, so you kind of had to find the other ones to do number 19, right?
Yeah.
Last is 20. I know we're packing up over here for 20. 20 was another proof. So if we just look at it out loud quickly, triangle ABC is a right isosceles triangle. What can you tell me about a right isosceles triangle?
45 degrees.
Yes, both of the other angles are 45 degrees. Does everyone know that? Okay, so I have 45, 45, 90. Also, if it's right, what theorem can we use on it? What theorem? Pythagorean theorem, if necessary. Hypotenuse is AB, labeling that. M is the midpoint of AB. M is the midpoint of AB. Write a coordinate proof to show that CM, we'll see right here, to show that CM, obviously my drawing's not to scale, so forgive me, is perpendicular to AB. Right angle, question mark? Right angle, question mark? Write a coordinate proof. Now, we didn't do a coordinate proof yet here. Kind of did actually when we did distance formula, and I derived distance formula from Pythagorean theorem. So we will do that tomorrow. The packet I photocopied and gave you, everyone has that? I'm going to give you homework out of that, okay? I will give you homework out of that. We should be able to do a lot in there now.